A stone is tied to a string of length L in a vertical circle with the other end of the string at the center. At a certain instant of time, the stone is at its lowest point and has a speed u. The magnitude of change in velocity at it reaches its highest point of the circle is. So first I am going to make the diagram. Suppose this is the situation and this is the center C. I am going to consider the length of a string is L. According to the problem, the initial velocity at A is ui cap if I use the vector representation, right? So now velocity at point A, that is ui cap. U is the initial velocity, I cap is representing the direction. Speed at the highest point I want to calculate. Suppose this is my point B. So B को हम लोग एक origin की तरह भी treat कर सकते हैं. So now if I go for the speed at highest point and if I use equation of motion VV square U square plus 2AS. So U square is there minus, because acceleration due to gravity acting downwards, so I am going to use minus sign, 2g, and I need this S because L is the length of a string, so that will be L. We can write S is equal to 2L, right? So speed at point B is root of U square minus 4GL. But if I represent in terms of vector, so vector V is along I cap, but यहाँ पे हमने इनिशियल पॉइंट A पर लिया है, तो राइट साइड विल बी पॉजिटिव x एंड लेफ्ट साइड विल बी नेगेटिव x. So we'll write here minus root of u square minus 4gl I cap, and I need change in velocity. So we'll write final velocity, that is at B, minus initial velocity at A. So first I am going to place the values, minus root u square minus 4gl I cap minus u I cap. So this is the change in velocity. But if I go for the magnitude of this change in velocity, because क्वेश्चन में बोला जा रहा है कि आपको कैलकुलेट करना है the magnitude of change in velocity. So when I will take the magnitude, so we'll get u plus u square minus 4gl, and this is the magnitude of change in velocity. Because कोई confusion नहीं है, I cap दोनों में है, I cap को आप कॉमन ले सकते हो, और उसके बाद मैग्नीट्यूड जब सॉल्व करोगे तो रूट कोफिशिएंट ऑफ I cap एंड कोफिशिएंट ऑफ I cap होगा u square minus 4gl and minus ui cap. So then you will get this. So my option number 4 is correct. Let's move on question number 22. A ball of mass m is attached to a lower end of light vertical spring of force constant K. Suppose this is a spring and ball is there. Spring constant is K. This is the initial introduction. The upper end of the spring is fixed. Okay. The ball is released from rest. Released from rest with the spring is at its natural length. The ball comes to rest momentarily after descending through a distance x. Through a distance x. At this position, acceleration of the ball. So if I go for the free body diagram of the ball, so force mg will act and force applied by the spring is kx in this direction. So now I am going to use the work energy theorem. According to this, work done is equal to change in kinetic energy according to the work energy theorem. So first I will calculate work done by this weight mg. So that is mg into x, and second I need work done by the spring force because you are saying that हम लोग देख पा रहे हैं कि जब स्प्रिंग डाउनवर्ड डायरेक्शन में एक्सपेंड होगी ड्यू टू द वेट ऑफ दिस बॉल, then spring will apply a force opposite to this change. That's why I am going to use the negative sign half kx square. हमें पता है कि जब स्प्रिंग के वर्क डन की हम लोग बात करते हैं तो एंगल बिटवीन द एलोंगेशन एंड फोर्स विल बिकम्स 180 डिग्री. So that is why we are going to use minus sign, and that is equal to change in kinetic energy. Initial and final दोनों केस में स्पीड 0 है, so we can take change in kinetic energy is 0. So I have a relation mgx is equal to half kx square, right? So we'll calculate x, that is 2 mg upon k, and this is my relation number 1. Spring force at this instant, this is my second requirement. अब मैं ये जानना चाह रहा हूं कि इस टाइम पर स्प्रिंग फोर्स कितना है. So for this purpose, we will continue with the next page. So I am going to calculate spring force at that instant, that is kx. Or as I discussed in the previous board, x is equal to 2 mg upon k. So if I want to calculate kx, that is equal to mg. So spring force at that instant is only 2 mg, but the direction of this force is up because स्प्रिंग अपने चेंजेस के अगेंस्ट में वर्क करेगी, तो ये फोर्स होगा स्प्रिंग का ओनली 2 mg. बट मुझे चाहिए एक्सेलरेशन. सो एज पर द डायग्राम, बिकॉज दिस इज द फोर्स applied by the spring and this is another force is mg. So when I will go the acceleration, will write net force on the ball. So according to sign convention, we'll take force applied by the spring is positive and another force is mg divided by the mass m of mass of the ball. Spring force is given by 2 mg minus mg divided by mass. So 2 mg minus mg mass cancel हो जाएगा, आपको मिलेगा only g because the direction of this force is up. So acceleration of the ball is upward. This is my final answer. So on behalf of that, we can say my option number 3 is correct. So let's move on. Question number 23. A force acts on a body of mass 1 by 2 kg in such a way that the position of particle is given by this. X in meter, t in second. Work done on the body during the first 9 seconds. 9 seconds. So in this type of question we can solve by using work energy theorem, and work energy theorem is given by change in kinetic energy is equal to work done. Work done by the all forces is equal to change in kinetic energy. So for the calculation of change in kinetic energy, I need mass, final speed and initial speed. So first I am going to calculate initial speed and then final speed. But position is given, so when you will differentiate this, we'll get the velocity equation dx over dt. When you will differentiate, we'll get 3 minus 8t plus t square, right? So if I go for initial velocity, we'll place the value of t is equal to 0. जब हम टाइम की वैल्यू 0 लेते हैं तो वो हमें इनिशियल स्पीड को देगा. तो अगर हम लोग यहाँ टाइम की वैल्यू को 0 पुट करेंगे तो विल गेट ओनली 3 मीटर पर सेकेंड, and this is the value of b1. Similarly, if I place the value of t is 9 seconds as per the question, then we'll get our final speed. हमें final speed चाहिए, but कब चाहिए? Question के according 9 सेकेंड पर चाहिए. तो this is our final speed. तो हम लोग t की वैल्यू को 9 यहाँ पे प्लेस करते हैं. 3 minus 8 into 9 plus 9 square. जब हम लोग इसको सॉल्व करेंगे, विल गेट 12 मीटर पर सेकेंड. सो दिस इज अवर फाइनल स्पीड, एंड नाउ आई एम गोइंग टू प्लेस द वैल्यू इन दिस रिलेशन, एंड दैट विल गिव यू द वर्क. 1 by 2, I need the value of mass, that is 1 by 2 kg. Final speed is 12. Initial speed is 3. So when you will solve, we'll get 135 upon 4 joule. So this is the amount of work done on the body during the first 9 seconds. So my option number first is correct. So let's move on question number 24. A long plank begins to move at t equal to 0, accelerate with a speed given by 2t square plus 2 meter per second. A small block initially at rest, we'll see, initially at rest on the plank begins to slip at t is equal to. Contact of block and plank has, so you can see, contact of block and plank has coefficient of static friction is 0.4 and for kinetic 0.3. You can take the value of g is 10 meter per second square. हम लोग को पता है कि जब भी नीचे वाला ब्लॉक अगर मूव करेगा देन देयर विल बी ए रिलेटिव मोशन. जब रिलेटिव मोशन होगा तो फ्रिक्शन विल टेक प्लेस. तो इस ब्लॉक को मूव करने के लिए या साथ में मूव करने के लिए रिक्वायरमेंट होती है फ्रिक्शन फोर्स की. सो वी कैन यूज डायरेक्टली दिस रिक्वायर्ड फोर्स इज गिवन बाय द फ्रिक्शनल फोर्स म्यू एस एम जी एंड force we can write mass into acceleration, so that is mu s mg. For according to the problem we can use this relation, and we know acceleration is given by dv over dt, that is equal to mu s mg. So we can write this relation, mass m will cancel out and I have only dv over dt, that is equal mu s into g. So when I will place the value of this v, d over dt, that is 2t square plus 2, mu s is 0.4, g is 10. So when you will differentiate, we'll get 4t is equal to 4. 4 will cancel out. So time t is 1 second. So plank begins to slip at 1 second. So my option number first is correct. Let's move on question number 25. So now I am going to read the question number 25. The bob of a simple pendulum is given a horizontal velocity root 4 gl at lowest point. Tangential acceleration of the bob at the moment when a string becomes slack. So this is a very good question. So we'll see the diagram first. This is, suppose this is the center, and if I consider strings becomes slack when it's make an angle theta with upward vertical. So this is, according to my assumptions, this is angle theta. So bob, weight of the bob will act like this, mg. And this angle will be theta, this is, and this is the tangential velocity v, right? And as you know, this is the length L, and if I consider from center O, this length or height is only L dash, and if I consider this is my reference line, इस लाइन से मैं हाइट को भी कंसीडर कर सकता हूं. Now if I consider this is h, so I would repeat, I am going to solve this question for a consideration, and I am going to consider a string becomes slack when it will make an angle theta with vertical. Okay, so first if I resolve the component of this weight, then we'll get a component of weight mg cos theta will be here, mg cos theta, and that will manage the centrifugal force. हमें पता है सर्कुलर मोशन में राइट साइड में एक फोर्स लगता है mb स्क्वायर बाई r से हम लोग जिसको लिखते हैं, तो यहां पर मैं लिख सकता हूं mg cos theta, that is equal mb square by l, because in this time radius is l, because length is the simple pendulum is l, so we will write here mb square by l. And one thing, सिंपल पेंडुलम में इस क्वेश्चन में आप देख पा रहे हो, गिवन ए हॉरिजॉन्टल वेलोसिटी in this direction and that is u is equal to 4 times of gl. ये भी हमें दिया जा रहा है. यहां पर मैं मास को मास से कैंसिल कर सकता हूं, तो we have g cos theta is equal to v square by l. तो मुझे मिलेगी स्पीड v square is equal to l g cos theta and this is my relation number 1. तो मैंने इस पर्टिकुलर पॉइंट पर स्पीड को फाइंड कर लिया बाय यूजिंग दिस कॉन्सेप्ट. ओके, आगे. अब अगर मैं यहां पे इक्वेशन ऑफ मोशन का यूज करूं, सपोज v स्क्वायर u स्क्वायर माइनस 2gh, तो मुझे पता है इनिशियल स्पीड क्वेश्चन में दिया जा रहा है √4gl. यहां पर स्क्वायर है, सो देयर इज नो नीड ऑफ the root, so we can write directly 4gl, right, minus 2g. अब मुझे चाहिए हाइट, h का वैल्यू मुझे चाहिए. h को कैसे सॉल्व करेंगे? अगर मैं सिर्फ इस ट्राइंगल की बात करूं एंड इफ आई यूज cos theta is equal to base upon hypotenuse. So if I use only this triangle, I am talking about this triangle, only this. So we will use base L dash and perpendicular is equal to L because L is the radius of the circle. So we have the value of L dash is L cos theta. डायग्राम में हम लोग इजिली देख सकते हैं कि फ्रॉम बॉटम टू द सेंटर हाइट इज L and next part of L dash is equal to L cos theta. So we can replace the value of H by L plus L cos theta. So if I use the here, so if I take L as a common, so we'll write 1 plus cos theta. So this is the value of height and this is V square. So we'll continue for the next page. V square is equal to 4gl minus 2gl 1 plus cos theta. But as I discussed, in relation number 1, the value of v square is equal to L g cos theta. So there is no need of root because this value is equal to v square L g cos theta and that is equal to 4gl minus 2gl. अगर मैं ब्रैकेट के अंदर मल्टीप्लाई करूं, minus 2gl cos theta. Now I am going to arrange the value of cos theta. 2gl cos theta and lg cos theta. तो ये हो जाएंगे 3lg cos theta. And on the right hand side 4gl subtracted by minus 2gl, so that will give you 2gl. gl will cancel out, so I have the value of cos theta, that is 2 by 3. So now if I want to calculate the value of sin theta, आगे मैं बताऊंगा मुझे क्यों जरूरत पड़ेगी, तो विल राइट 1 माइनस cos square theta. So 1 minus the value of cos theta is 2 by 3, so that is 4 by 9. On solving, we'll get √5 upon 3. This is the value of sin theta. So I am going to repeat this. This is our diagram. मैंने यहां कंसीडर किया था फ्रॉम वर्टिकल से एट एन एंगल थीटा इट विल स्लैक, द स्ट्रिंग बिकम स्लैक. सो दिस इज द कंपोनेंट ऑफ वेट बिकॉज दिस एंगल इज थीटा, दिस इज थीटा. तो मैं यहाँ पे एक कंपोनेंट ले सकता हूं mg cos थीटा, जैसा मैंने अभी बताया. सेकेंड कंपोनेंट होगा mg sin थीटा. तो आप देख सकते हो जो टेंजेंशियली फोर्स है वो है mg sin थीटा. तो इफ आई गो फॉर टेंजेंशियल एक्सेलरेशन बाय दिस डायग्राम, तो टेंजेंशियल एक्सेलरेशन इज कैलकुलेटेड बाय टेंजेंशियल फोर्स टू द मास. टेंजेंशियल फोर्स है mg sin थीटा, मास कैंसिल होगा तो मुझे मिलेगा ओनली g sin थीटा. g sin थीटा इज द टेंजेंशियल एक्सेलरेशन, but I have the value of sin theta is √5 by 3. So when I will place the value g into the value of sin theta is √5 by 3. So my final answer is √5 by 3 times of g. So this is the value of tangential acceleration. So on behalf of that, we can say my option number third is correct. So let's move on question number 26.